I guess we are here. All good to start. Great. First of all, thank you everyone for joining in for this session with this talk. This is going to be very interesting talk. I am Nishant Srivastava. I'm an Android engineer working at Bimi Hearing Technologies in Berlin. And today, what I'm going to be talking about is that about Compose and how does it translate into the desktop world. I want to be very clear about how this talk is going to be structured. So this talk is not going to talk about building UIs, but it's actually going to be talking about how do you work with desktop and then build UIs on desktop applications, right? So this is where we're going to start with. But even before we dive into the Compose for desktop, we need to understand where it all started from, right? The origin of all of this setup around UI development in general. And the origin of this whole concept itself started from one platform, that is Android, with a UI framework that was kind of thought through in terms of moving away from what we used to do in Android for a couple of years. And this is more or less now being changed with something that's called as Jetpack Compose. So for those of you who actually have no idea what Jetpack Compose is, considering if you're coming here to for understanding how UI development for desktop would work, I'm going to run through a quick summary of what Jetpack Compose is. So Jetpack Compose is something that was built for Android initially. It's like a modern toolkit. The API is inspired by React and Flutter. I say this because the core developers for Jetpack Compose have also worked on React framework. And then a lot of the API structure, as you see it now, is also kind of inspired from Flutter, because that's was where the whole testing was done in terms of like how developers are going to be experiencing this development process. It's a declarative and reactive UI framework, a kind of something that simplifies the whole process of how Android used to work with UI development. We used to have XML, we had various framework come in, data binding, and I don't know, like a couple of many others that came up. And it just tries to change that whole landscape. It's built using one of the languages that Android developers love a lot. It's built using Kotlin, and as of this talk, it's already released in stable channel. So something like a very nice stable base to build upon in future for something that could be composed for desktop. So a very quick rundown on like how Compose for Jetpack Compose in general came to be, right? So if you had to build a UI for Jetpack Compose today, you would just fire up Android Studio, start the wizard, and you will have empty Compose activity that you can select. And when you finish the wizard, what it will do is it will set up your project, and you will have a class called main activity, which is your entry point in an Android application, where you will have the code that looks like this. And you will notice that it has some parts here and there, but what is important is that the main activity is extending from component activity. And then there's a block which is called set content. And inside that set content block, inside the Lambda, you have something that looks like a class with a constructor initialization, hello world. But we'll see that's not true in this case. In Android world, set content actually kind of works in a way that you would set it with an XML file in before Compose, Jetpack Compose came to be. But in this case, everything is in your code. There is no XML file that is even generated as part of the wizard. So what is hello world actually? So hello world is a function that is annotated with @composable um, keyword here, right? And then inside that composable function called hello world, there is something that looks again like a class with a constructor initialization. So text in this case, with a parameter being passed as hello world for text named property. So I say composable, that in general, what does it means, right? It means that it's basically something, a component that's modeled by a function, and the state is passed in as a parameter. Okay, good in theory. How does it look like in actual implementation? So you can see in our last example, text is actually a composable function, and then the state that is being passed to this composable function is the text equal to hello world in this case, right? And I'm mentioning that this is not a constructor call. So when I say that in general, why I keep on saying that this is not a constructor call, because we can look into the source code and figure out exactly what it is. And when I say text is a composable function, if you look into the source code, you can see that it is also a function with annotation at composable to it. So as you can see, there are other parameters also that you can pass, which is part of the state, and that kind of like defines what the text would be like. All of that is good, but what we need to understand here is that Jetpack Compose is not just a single UI framework, but it basically is something that's built upon multiple things. Another thing that you can actually also do here is that you can preview your composable function in a certain way. So in this case, you can annotate it with at preview annotation, and then Android Studio has this tooling that allows you to preview the function that you just built, the composable function. So it's going to draw something into a preview pane. As I was saying, that there's like the different parts that Jetpack Compose is made of, right? And if we had to split it out into exactly what different parts are, Jetpack Compose is basically built with Compose compiler plugin, and then you have the Jetpack Compose Android part of it. So there's the UI framework that actually does your widgets, your text, your buttons, your background, your layouts like cards and other kind of like lazy rows um, and list views. In this case, that's Jetpack Compose. But then there's a section of this whole framework that is called the Compose compiler plugin, which works with slot mechanism. It does a lot of different things. But the gist of this whole Compose compiler plugin is that it understands when something changes and it triggers the update for that change, right? So that functionality is what is encapsulated in the compiler plugin. That's a good idea, because that basically means that if we could actually replace Jetpack Compose Android part of it, the widget part of it, with something that works on desktop, this should technically work in theory, right? Like you have the compiler that can understand when a change is triggered, and then may apply the change to a certain parts of the view hierarchy, to the view tree. Then we should be able to replace Jetpack Compose with something that we call Compose for desktop. So that's technically, like as we are saying, is what's bringing us to a situation where we say Compose compiler plugin is kind of the common concept, and then from there onwards we can actually build something widget wise on an Android platform, on a desktop platform. And this is where we are diversifying. We are basically saying that our widgets now, which are platform specific, could be implemented while using the same concept of Compose declarative and reactive UI framework. That brings me to the topic of this session, which is Compose for desktop. So Compose for desktop is basically built upon Jetpack Compose for Android. As I said, the Jetpack Compose for Android is where the technology incubated. It started and it got stabilized at this point. And Compose for desktop basically takes that same concept. The Compose compiler is what it takes, and then it takes some parts from Android as widgets and some parts for specific for desktop compilation, right? For desktop, you might have a completely different set of widgets and actions to it. You might have hover action with your mouse. You might have drag and drop with a completely different multiple windows setup, right? That's what Compose for desktop is building on top of the Compose compiler. And it also tries to simplify the whole desktop UI development. Like up till now, we have had many different UI frameworks. This is not the first time when Compose is revolutionizing something. It's like there have been other frameworks that tried to do it in the past. It's just a different approach that also works on a different platform. Um, and as of now, Compose for desktop is in beta right now. You can see like maybe it's even more now. Another release was made today in the morning or maybe yesterday, which says dev 455. So it's moving really fast. The repository that you can keep looking at is the JetBrains Compose -jb, and they keep on making new updates, but as of now it's in beta already, so API stable as we call it. So if you had to build something for desktop today, right? You just fire up IntelliJ IDEA, maybe Community Edition, or if you have the Ultimate, both works. And then going through the wizard, you can basically just go and select desktop version, Jetpack Compose for desktop. And then as you can see, it's experimental, but you have the option to select it. And then you choose the project JDK. Lower than JDK 11 is actually causing problems, so you should not do that. Select JDK 11, but recommended is to even go higher and use JDK 15, which I'll talk about why am I saying there in a bit. So you do that, and then you do next, and like you finish it, and This time onwards, you don't have any activity. You are on your standard desktop platform. You're on macOS, you're on Linux OS, you're on Windows. And this time you don't get main activity as part of the project, but you get like a simple main kt file, main.kt file. That's your Kotlin file. So what we are saying here is that the entry point has changed, and this is where actually things will start to change. So this time onwards, you will actually start with something which is in a standard Kotlin or a Java platform is a main function, which is your entry point. So in this case, we say function main, and then we call a different set of UI. In this widget, we say single window application. It's not extending component activity as in Android. It's basically saying you start with a different set of widget and you say single window application. You set the state for this, in this case, title being Jetpack desktop window. And then we have the same function that we had before, the composable function hello world, which looks the same. I want to highlight something here though. One is that the text widget is actually coming from the Android Jetpack Compose library right now. uh, this is something that's kind of shared right now between desktop and Android. It's quite similar, so it makes sense to share this across. And then notice that the compose.runtime composable is coming from the plugin. So that's basically justifies the theoretical part that we were saying, that there's a compiler plugin and then there's a widget part of this. So this is how you can see that exactly Compose for desktop is doing that kind of thing. Another thing to note is that I've highlighted this is that the package name starts with Android X. Again, going back to the same concept, that Compose for desktop actually originated from the Jetpack Compose, which was built for Android platform. And the package name just says Android X right now. In future, it might change based on how diversified these two frameworks are going to be. But for now, just think of it as they are kind of using what Android has already built, and they don't want to change the package name completely. So you have Android X. Okay, great. So now that you have your basic, the most bare minimum version of the application code, how do you run it? Again, because you don't have the application module or app activity in this case, you cannot just go ahead and run app as you would do in an Android application, right? So what you do is that you run your main kt file, in this case, as I highlighted, and then when you run it, you build it and you run it, you get a window that's similar to Linux. On the top one, you can see that's a Ubuntu-based Linux, and shows your desktop application with a maximize button, minimize button, close button, and then also you can resize it. It also has a title. And then on the lower one, you can see is the one that's would be visible on macOS. So the UI aesthetics of how the title bar is set up, how the system tries to set up the UI elements around your application is going to change based on the operating system you're running, but it's still the same code. Based on where you are running is exactly where this will end up looking like. Okay, so what about preview? Because we could do preview in Android, right? And there was tooling for this in the Android Studio. So when the JetBrains as a team, when they tried to do this within the IntelliJ IDE itself, they had to like do some hacking around to make it work. The initial version was a very much limited to the IntelliJ version itself. And then later on, what they did was they tried to extract the whole functionality, the annotation itself, and then they put it into something that they call Compose Multi-Platform IDE support. And we'll also get to Compose Multi-Platform, why they say it this way now. But yeah, that's what they do. And they this one plugin, when you install it in your IDE itself, it enables the preview of composable function that are marked by preview annotation. Quite easy to do that. It has more support to it than just the preview annotation. So if you look into the details of exactly this plugin itself, you can see that there is something that's the preview entry point. And then there are section that talks about run configuration, producer, run line marker contributor, tool window. This is the preview tool window that you can see yourself when you're using preview. And yeah, it provides you multiple functionalities that's related to previews in general. Let's just say that. Also notice that that the package name here says com.intelj.dead code. So that's like just a fun fact that I just found, and I was like, well, sounds interesting, because your preview is basically dead code. If you look at it, it's not functional code, it's a preview of the UI itself. So if you had to do that, how would you do it? right? You would just go to a composable function, add the annotation, add preview to it, and then you cannot actually run this whole code. I mean, that just defeats the purpose of the preview, is that it will not auto load the preview for you. In Android, sometimes it will do. We have live previews that could do that. If you change a value inside a state, it might update that for you. That does not happen right now for Compose for desktop. You actually get that marker in the gutter area. You can see there's an icon that says show non-interactive preview. So when you click on that is when you can actually see the preview in the preview pane. This pane also would not exist in the first time you try it, but when you run it for the first time, it will actually build your composable function, and then it will run it to you. So desktop preview is also available for now. Okay, all good. You can write code for it. You can preview your UI composables that you have, and you can kind of build the application. But what about distribution, right? So to start with that, we need to go into the projects build.gradle.kts file. Once we have finished with the wizard and everything, build the application, there's a section, a block that is dedicated to compose.desktop. And I want to highlight two things here. One is that it talks about the main class, the entry point for your application. Again, you would do something similar inside your manifest file, but there is no manifest file here. You are on a desktop platform, so you need to mention the class that is going to be used to start your application, in this case being main.kt. And then there is a section that is for native distribution, that talks about how would you distribute your binaries once you're finished your developing your desktop application. How do you distribute them? So to that, you have this section again. There's a function called for target formats. You can define DMG for macOS, MSI for Microsoft Windows, and DEB, which is for Debian Linux based distros such as Ubuntu. But you're not limited to these. There are more, because as we can see, target format seems like it's some sort of an enum. So we can jump into the source code of this, and we can find that, well, there are other formats that you can also distribute. You can distribute as an app image, as an RPM, as a PKG file, as an exe for Windows, all the different formats that you can package your application and be able to publish it out. Again, all of the stuff that you are packaging is also containing your code for Compose with this. You are basically writing something that is going from end to end. You write the UI, you write your business logic in your code base, and then you package it out into something that can be consumed by other people. So once you have done all of this, like, you know that you can generate all of this, like how do you actually generate the package for it, right? So because of these the target platform that you have set up, you have access to some Gradle task that it generates. So you have the access to package deb, dmg, msi. If I had target format set to exe, I would get package exe. If I had one for app image, I would get package app image. And once you build all of this stuff, you can run any of these. Package would run db, dmg, and msi, all of them, but you can also individually run them. Once you're done with this, what will end up is that all the binaries would end up being in the position on your directory of build compose binaries main package type. um, Something that I really do wanted to mention is that if you build it with jdk 11, it will actually crash. For some reason, as of now, this is limited to having jdk that is more than 15. So this is why I said during the installation, during the time when you were creating the project, you should choose jdk 15. That would just simplify the process. A solution for this case is that when you are generating the binary, when you're running Gradle package or package deb, you need to set the jdk in your terminal session at that time to 15, and it would also work. Like, it's not really bad. It's just you have to explicitly set it in your terminal session to run it from the command line and be able to generate it. If you run it from the IntelliJ IDEA itself, it will give you this warning. So there are ways to fix it, but if you want the smooth road, just basically do one with jdk 15, create one with the jdk 15. Okay, so we said that there's going to be binaries that would be generated. So we can take a look at one in the macOS right now. We have compose binaries main dmg, and then there's a dmg for it. So basically you have a desktop application and you have a distribution for it already. But that's all how we work with Compose for desktop. We have things that we can work with, but why are we even doing this? Like, what's the basic need of doing? The answer to that actually lies back into like what traditional desktop UI frameworks were doing in the past. So they were basically doing, they had widgets, they had graphical components that were encapsulating state. And then in order to change something, they had like some sort of function to change the state. For example, you had, I don't know, for example, I'm going to create an example, in this case be um, a text view that encapsulates the text value for it, right? In order to change it, you will say text view dot set text. That's a function call to change the state. And that's not like a very composable approach. It's very object oriented programming approach, where you kind of like call a function over the actual component and then change the state. This basically also means that you need to traverse the whole tree to trigger the change. Compose does not do that. Compose basically if creates the view in with the state that you pass into it. It does not have functional call to make those changes. So it's very efficient in that sense, and it can do a diff, and it can create some values out of it and then change values for it. So what are the other traditional desktop UI frameworks that we know of? We know about Swing, we know about AWT, we know about SWT, Tornado FX, Java FX, and sometimes people also do their own version. They do callback driven development. We know Electron, everyone knows that. You have Qt, you have GTK, etc. You have many of these that have tried to do work, but they were all doing it in a very different way. The Compose for Desktop is a completely revolutionizing way of building UI. It's also really fast. So what is the magic behind this? Well, the general thing that actually powers the whole Compose functionality is the Skia library. It's a 2D rendering library. This is basically open source under BSD license. It's maintained by Google. It was not originally built by Google. It was built by Skia Inc. And then Google kind of like acquired the company, and then they've since then used it in many places. It's completely open source for sure. Like you can go ahead and use it if you want it, if you comply with the BSD license. This is also the graphics engine for Chrome, Android, Flutter, Mozilla Firefox, Chrome OS, Firefox OS, etc. Like many of these existing products, they already use this. And the reason Skia is able to do that is because Skia is written in C++. So what it does is it basically abstracts away the platform specific graphic APIs. It doesn't care about the platform specifics. And this basically allows Skia to do the same kind of stuff in all the different platforms. And then platforms provide the APIs to actually make changes. Okay, so Compose or Jetpack Compose originally started on JVM, right? Because Android, so JVM. And for that, in order to work with Skia, which is a C++ library, a 2D rendering library, they had to use Java bindings for Skia. So it's called Skija or something like this. um, and they were using this for a very long time, but this has limitations because it is now limited to JVM. You're talking about Java bindings in this case. So JetBrains basically wanted to expand into different platforms. So what they started thinking was, is how can we actually transfer it to Kotlin, which can also compile to other platforms. Kotlin is not limited to JVM anymore. It can compile to other formats like JavaScript and like multiple platforms, native platforms. So they started slowly moving to Skiko, which is the Kotlin binding for Skia. And this is more of a multi-platform library for Skia, and it does Windows management basically. It supports Linux, Windows, macOS, and also builds for Kotlin JVM. It's all available in this case. Yeah, there's a link in the slide, and you can check this out later also. So why Skiko is so important? Like, why not just make some changes to, like, say, another library or directly in Skia? The thing is that up till now, if you had to make changes, you had to do it like, if it was Skija, you had to do things related to JVM. But as soon as you move into Skiko, which is your Kotlin bindings, in this case, you have the ability to start talking about other platforms because it's multi-platform overall. So now you have, like, for example, this is a pull request that basically builds in Metal API prototype. Metal is a native implementation for macOS, and this functionality is now merged into Skiko and allowing to leverage the Metal API using the Skiko bindings here. So the iteration process is much easier. No one has to worry about what the underlying platform API does. They just need to understand how Skiko works, and then almost all the platforms that are using Skiko, they just get benefit from it. Fun fact, this is something that I found out, is that when you're working with Compose for desktop, you use a window widget also. The single application window internally also uses window widget, and that window actually extends from Compose window, which in turn extends from Swing's JFrame. Okay, this is also from the source code. I kind of highlighted it, that internally Compose for desktop is using widgets that still use things that were built in the past, using Java Xswing, and it is kind of like making things easier for you. It's changed the way that the JFrame was being used earlier, because now it's using composable functions to trigger that UI development process here. But you're still using JFrame. You're still using Swing JFrame. So what's next from this, right? Like, we have Compose for desktop, we can just go ahead and make something for desktop, but we also have Jetpack Compose for Android. So we have two platforms that we're covering, but there's obviously possibility to go beyond this, right? We have the Compose compiler plugin that can do many things, and it has already proven that it can move into different platforms. It did Android, it can do desktop, and by desktop it means Linux, Mac, or in this case Windows also. um, so what's the exact next step for this? Well, the next step is that, think of it as that the compiler is now going to be expanding into different other platforms that maybe we didn't think in the beginning when Jetpack Compose came to be. For example, it could be Compose for web, or it could be some other new platform. And taking this into the whole account, JetBrains actually thought about this, and they kind of renamed Compose for desktop in a way that they call it now Compose Multi-Platform. This is visible on their website also. You can see it says fast reactive desktop and web UI framework for Kotlin. And they kind of also have now started pushing for it more, for saying it's Compose Multi-Platform. It's going to be targeting multiple platforms. There is also Compose for web, which is already in works. It's a technology preview right now, but it is there. You can already see it being used. In fact, the last release, or like couple of releases that have happened for Compose, Compose for desktop repository, they have been working heavily towards making Compose for web much more stable. Right now it's in technology preview, but there are a few things that it needs to be done and updated with. So all of this is happening right now. Things are changing in the same time, and all of this is functional versions, although they are not stable APIs right now. But that's not it. You're not limited to this. You have some other people, those who have actually tried to use the Compose compiler plugin and use it to build something else. So in this case, again, the compiler plugin decides when the change happens. And in this case, Jake Wharton has built a project, Mosaic, which helps you build console UIs using Kotlin, right? So you have like some way of now building terminal-based UIs while using Kotlin language, and be able to just make your scripts look much nicer. That's a possibility, and it's fully functional. It's experimental tool right now, as in that's how it's written in the README, but it does work. So you have the possibility of expanding your platform into many different directions at this point, and you're not limited to just Jetpack Compose on Android. You are going into desktop. You're going into terminal UI. In fact, it is not always about UI. I want to go a step further, because this was released just yesterday, I guess, at least on the blog post it came to be. But Square Engineering is also doing things that's not related to directly UI, but more about change in the state itself. So this project is called Molecule, and this was published, I think, yesterday or day before yesterday by Cash App, which is from Square Engineering. And they basically are using the Compose compiler plugin to trigger updates in the states. Instead of having to write like so many different lines of code in your view model and everything, they just basically use the Molecule framework that they have built to build state flow or flow streams, and only make an update in these streams when a certain change is there. Again, making use of the mechanism that compiler plugin is able to do, Compose compiler plugin is able to do, and using the efficient mechanism that is built around it. It's in a way that it allows you to completely rethink how you can change and how will you build your application now. It could be your Android application. In this case, it is, I think, more geared towards Android applications. But apparently, this whole system could also be carried over to desktop. So again, you're not limited to Compose that just lives on Android now, but you're going into different platforms, which is favored towards multiple platforms. That's why it's called Compose Multi-Platform now. So what next? Yeah, so you can definitely go ahead and try different examples that exist inside the Compose JB repository. There are many examples that they keep on updating, but there are also people, those who are also building multiple applications. So in this case, it would be something similar to, let's say, you could build an Android application, and then you can actually carry this code over to the desktop version of it. The only thing that you need to change is the entry point and how you're going to be working or interacting with your application on a desktop, because you have mouse, you have keyboard support, and also there are some things that you can do on a laptop, on a machine, that you cannot do on an Android phone, right? So some of those things are very important when you make those changes, when you transfer code from Android to your Compose for desktop application. You have to write in a way that maybe you can split your UI in a different panes. Like for example, the code viewer example does that. You also have like applications like to-do applications that you would write on Android quite easily, but you can also do it for desktop. Notice that the UI also extends with it, so that's where you need to make changes. You need to do consideration, but the technology exists for you to work with and play with. There are other people, those who have also been building applications. So this one application is built by someone in the community. This one is called StackZ. What it does is that basically takes your APK files, and then it inspects exactly what libraries you are working on. So you could be working with OKHTTP, JSON, or like Exoplayer or something. It just lists out your stack for your application, and it's a very nice way of representing something in a desktop application. You could just load an APK and just visualize things inside the APK. Um, I even built an application sometime back, which is kind of, I took the reference UI from a web-based application. So this is when you have buy me a coffee UI. So you can see there's a reference UI, and I took that UI, I built it for Android first, and then I copy pasted this code into Compose for desktop, right? So you can see that it basically builds as a as a UI element, as an application that can run on a desktop. I can resize it, I can do things with it, and it basically shares the code the same way as Android does. The code exists right now in Jetset Compose repository. You have the link here that you can use, but the power of using your Compose UI is now also expanded to desktop. And I would actually suggest that people go ahead and try all of these different versions as much as they can. um, and I guess that's all of it. There's so much different resources that you can actually check out, but most of it stuff you can actually find it through my repositories on GitHub. You can find me on nishrules.com, or just Google with the keyword nishrules and you can still find it. And I guess that should be it for the talk.